heat energy flows. After learning this, let us now learn how these quantities are associated with a system through the concept of specific heat. Let us perform the activity. To learn about specific heat, take a big jar, fill it with water and heat up to 100 degrees Celsius. Take two similar boiling test tubes with single-holed corks. Now fill one of them with 50 grams of water and another with 50 grams of oil. Insert two thermometers into the test tubes via the holes of the corks. Now fix them to a retort stand and set them in the hot water of jar. For every 3 minutes, observe the readings of thermometers. Note down the readings in your book. When the test tubes containing water and oil are kept in the water jar of same temperature for equal intervals of time, they both receive same amount of heat. Here, we find that the increase in temperature of the oil is faster than the increase in temperature of the water. The increase in temperature depends on the nature of the material. Let us perform another activity to learn more about the specific heat. Take 250 milliliters of water in a small beaker and 1 liter of water in a large beaker. Measure their initial temperatures using a thermometer and note them. These two initial temperatures must be equal. Now heat both beakers until the temperature of water raises to 60 degrees Celsius. Observe the heating time required to increase the temperature of water to 60 degrees Celsius in each beaker and note the readings. We observe that the time required to heat the large beaker is more than the time required to heat the smaller beaker. This implies that the required heat energy is more for water in larger beaker than water in smaller beaker for changing the same temperature. In other words, for same change in temperature, the amount of heat absorbed by a body is directly proportional to its mass m. Q directly proportional to m when delta T is constant. Consider it as equation 1. Now, take 1 liter of water in a beaker and heat it. For every 2 minutes, note down the temperature changes delta T. We will observe that the change in temperature increases with the time. This implies the change in temperature is proportional to amount of heat Q absorbed by it for the same mass m of water. Q directly proportional to delta T when m is constant. Consider it as equation 2. From equation 1 and 2, we get Q directly proportional to m delta T. We introduce the constant of proportionality S. Q is equal to Sm delta T. Here S is a constant for a given material. This constant is called specific heat of substance and is mathematically given as S is equal to Q by m delta T. Consider it as equation 3. It is defined as the amount of heat required to rise the temperature of unit mass of the material by a unit. The CGS unit of specific heat is calorie per gram, degree Celsius, and the SI unit of specific heat is joule per kilogram. The units in different systems are interconvertible using the relation 1 calorie per gram degree Celsius is equal to 1 kilocalorie per kilogram Kelvin is equal to 4.2 into 10 to the power 3 joule per kilogram Kelvin. We know that the rise in temperature depends on nature of the material. That is why the specific heat of the material depends on its nature. From the equation 3, we learn that the specific heat of the body and rise in temperature are inversely proportional to each other. However, every material exhibits some opposition to rise in temperature as its nature. Let us learn about the reasons behind this observation through the concept of internal energy. We know that the average kinetic energy of the molecules of the body is directly proportional to the absolute temperature of the body. The molecules or particles of the system, body or material contain different energies such as linear kinetic, rotational kinetic, vibrational energy, and potential binding energy between them. The entire energy of the system, body or material is called internal energy of the system, body or material. When we supply heat to the system, body or material, it is shared in various forms. Such sharing varies from one material to another and with the temperature of the body. If the maximum share of heat energy is spent in increasing the body's linear kinetic energy, its temperature rises. For this reason, the specific heat is different for different materials. The equation Q is equal to ms delta T is used to find the amount of heat Q required to rise the temperature of a substance of mass m by delta